Smart fasteners. Once
I get the same feeling like really maintainable code or anything like that. I mean, it's like, yeah, it shows intent. That's the main. Yeah.
Great. Yeah. No, I agree. Thank you. And it's nailing down this process so that we can invite other people. Well, like you guys, for example, to do parts for this. We have to come up with a more robust workflow than I think what's going on in Fusion right now, because I don't want to trash talk Fusion. I do it, believe me, enough in my head, but there's there's a lot of ironing out that you have to do, especially for when you're making something that's not a bookshelf and you have 50 people working on it. It's some standardization has to happen, and I think that those single mega sketches with 50 sketch profiles, it's just, I don't personally think that's the answer. And I think part of it comes from people assuming that somehow that is less processor intensive, or that that's makes the timeline shorter and therefore is more efficient. Somebody used that term this morning, efficiency. And in reality, I don't think that that's efficient. It's maybe shorter, like there's some brevity there, but I think it's inefficient because it does not convey design intent. I think it's the opposite of that, actually. But anyway.
Yeah, I definitely see what you're saying. And by the way, for people on YouTube, sorry, we lagged out. YouTube ended the stream before I could reconnect. So now we have 2 streams today, and the other one ended without closure. And hopefully both of the people who are watching the stream will reconnect.
I think one of them was me.
Yeah, I'm probably the other one. We always have more people from the Discord server than in the YouTube channel, but that's fine.
Yeah. So
actually, we do get a number of people who watch this afterwards. I've watched it. There are people who actually go back and watch it. So I'm glad we're recording.
Great.
Yeah.
So back to where we were, though. So
we do have 2 viewers that aren't me. It's Kooky and Tom Nelson. Thanks, guys.
Nice.
Appreciate you being here.
So, yeah. So this is a smart fastener, and it's brought in by the smart fastener feature. It's part of assembly, and you can choose the length. You can actually choose to auto update the length according to the hole. So you actually don't really even choose what fastener. You just drill the hole, and then SolidWorks puts the appropriate fastener in there. I found that it's not necessarily always consistent. Like, for example, one time I did literally the exact same thing as another time. And one time it gave me a 20 millimeter fastener and everything fit perfectly. The next time it gave me a 25 millimeter fastener, and then there was 5 millimeters of interference. And that didn't make any sense to me. So I don't know why it did that. So I just selected the length because I know that that's how deep it drilled. There's a standard length of drilling that SolidWorks will do if you don't tell it to do something else, and that's dependent on the fastener. So like an M8 fastener like this is going to be, I think, a 19 point something millimeter depth, and it's just how it does it. You can tell it to go longer, and I think if you do, it probably that 25 millimeter fastener would probably be right. But either way,
in terms of
that's
the
what I
smart
chose,
fastener
and
feature, right? Let's say if you have a screw, right? You have a plate that you have a clearance hole, and then you have another plate that has the threaded hole in it, right? For it to update those other things, do you have to tell it that this is a threaded hole on the far side? And is that an argument for using the hole wizard rather than just trying to, make an appropriately sized hole in the sketch? You know what I mean? Do you have to tell SolidWorks that this hole is a whole entity which is threaded and it's M6? Like, do you have to provide that information on the front side?
I'll show you. Just give me 2 seconds here.
1, 2.
The answer to that is basically no. You don't have to do anything special.
Oh, so
here is our. Wow, my computer's really good.
Because I have definitely actually manufactured a part
and
drilled the holes at clearance size when they were supposed to be 1/4 inch tapped holes, and only realized once I was trying to put it together, saying, "Oh, these holes are too big. I need to tap these." But when I was designing, I just put a 1/4-inch hole in there, and then I didn't catch it in cam land, and I had to remake the part. Not my proudest moment as a machinist, but the thing about using the hole feature that I like is because it avoids that exact situation.
Right. I'm about to show you. I just need to make.
Always make the fastener holes undersized. That could also be a solution.
Yeah,
and then you have a pilot hole to make them correct.
As I'm designing stuff, like if I have to slow down and provide that kind of information, I get like it's like it breaks my train of thought a little bit. Sometimes it's just like I want to just put these holes in so that I can move on to the next thing. It's probably not a good habit.
Wow, my computer is so goddamn slow. What is going on? This is nuts.
I mean, I don't know if you have been using much of Discord streaming, but I mean, for my phone at least, that's the only case where my phone ever gets warm. It's when I even watch a stream on Discord.
On Discord.
So I think Discord is really crappy in performance-wise. I mean,
I can literally utter 5 paragraphs before my mouse even responds to what I'm saying. This is so stupid. Okay. Sketch is done. Now I do. Come on. Extruded boss base. Come on. Okay, let's go. Hell. Let's go 20. Okay. So own it. Let's. Copy it. Let's see another one.
Well, you're making two bodies that you're
come on.
Bolt through.
Oh my god! What is fucking going on? I'm sorry to to
and you know what's great?
Swear here,
I
but
know that you're the kind of person that gets frustrated with this anyway. But it's even cooler because you're doing it while streaming on YouTube, and everyone's watching you be frustrated. That makes it super cool.
Yeah, it's the best. I mean, what?
I mean, no pressure.
So,
or anything.
FYI, this is why I use remote desktop on the Mac, because the Mac can handle all of this multimedia stuff, and then I can use SolidWorks and do remote desktop.
Yeah.
But I mean, this is just dumb.
Well, I'm super impressed with. I mean, I have a much newer machine, the PC that I built last fall for SolidWorks. But I'm watching my control panel on YouTube. I've got OBS Ninja open. I've got Discord. I have SolidWorks open, and I have what else do I have? OBS, and amazing the amount of things that are happening simultaneously on this thing. I think we need to get you.
All right. Well, my
David.
Computer is literally sitting on an ice block right now. Wow.
Painful.
Actually, what's the state of that? Oh wow, it's totally melted.
Your ice block has melted?
Well, just a second. So it's one of these guys. Hold on. I gotta put it back in the freezer.
Put it in the freezer. I don't know.
No, why can't you just liquid cool a plate underneath your laptop? Like the cool kids do. I'm just kidding. No, there are no cool kids who do that.
Ice blocks.
There you go.
Okay. So if you ever order HelloFresh or any kind of those meal kits, they come with a block of gel that you put in the freezer if you want to keep them.
Yep.
And that's what it was sitting on, and it literally melted through that. And it's probably not great for the computer in the long term being around cold, wet stuff. But the thing is, look at what the computer's doing now. It's literally like frozen. And so I just put it on some even colder ones. These are from, this is what my, yeah. This is so dumb.
It's good. It's good.
Let me, no, because I want to explain this stupid fucking, sorry, this, I want to explain this feature. And in order to do that, I needed to make 3 fucking circles to drill through. And I can't even do that.
Oh, maybe I should do it. Maybe you can coach me.
Okay.
Should I make an assembly or a part?
You want to do that?
Yeah. Should I make an assembly or a part?
Make an assembly. An assembly.
Okay.
Wow.
I have on my monitor, I have my default resolution much larger, so maybe people on YouTube can actually see the commands. Also, it's gonna be easier to see. All right, so I have an assembly, so three different parts inside of it. Yes. That's part.
Okay.
So David, can you hear me?
Apple needs to come out with the M1X sooner, or the bigger one that they always talk about a 32 core version.
You mean the Apple Silicon?
Smoke everything.
Yeah, let's see. So I'm going to oops, what the heck? SolidWorks is throwing me an error. And I don't know where you ever do that when you have like
yeah,
like you don't know where the error dialog box is? New part. There we go. So
yeah, get it.
So 3 parts in one assembly?
Yeah, you were super low resolution, by the way.
Yeah, I need to call good old AT&T and ask them why the fiber optic internet service that I thought was going to be great for streaming is not as great as it should be. All right.
Yeah, I mean, I can't really even see anything. Can you make? Oh, I don't know if that's going to make a difference, but.
Are you watching my stream
you can
on
see
Discord?
the circle. You can't read anything.
Oh, because I'm super pixelated.
Yeah.
Interesting. Oh, maybe I'll stop moving stuff for no reason.
But I mean, I'm also on 4G from Sweden, so I mean, it's yeah. That could be the reason.
Yeah, it's a. And Cookie is saying that he sees me clearer and that it might be David. Wouldn't surprise me. By the way, SolidWorks Connected, even simple things like make new part are difficult. It takes time. All right, so this one's also 200 millimeters, but it's offset from that guy by 100 millimeters. And it's going to be... All right, so I have 2 different parts. Now, walk me through it, David. We're doing smart fasteners, right?
He said 3 parts.
3 parts? Okay. It's pretty bossy, if you ask me. All right, so we got that part now. New part, bar. Hey, Brandon, do me a favor. Can you grab one of the beers in there and bring it to me? Yeah. It's beer 30, the bluish one. Yeah. I punish people who walk through the background of my stream. Today's stream brought to you by Hazy Little Thing IPA from Sierra Nevada, one of Northern California's finest breweries. Oh yeah. Okay.
I don't know if Sweden is special because, I mean, I've tried a lot of American beers and most of them that are in Sweden or available here are really good.
Really?
I guess we are only importing the good ones.
A lot of times.
Yeah, I mean Sierra Nevada and Lagunitas and tail of a whale. I don't know. I mean, there's many of them.
A lot of times
We
the
had
good
someone
stuff never
called
makes it
Anchor
very far.
Steam before, but that one is not available anymore. I don't know why. That was really good.
I love the I have a feeling like the good beer and wine. So I'm a former winemaker, which is why I like beer. Never gets the best stuff, and actually sometimes on a national level, like Argentina makes some great wines apparently, but none of them leave. So
okay.
All right, so we are doing. I'm assuming David's going to come back. I think we just completely lost him.
I mean, we already lost him like a small while ago, so I guess.
Yeah, I know. Yeah. Well, I noticed actually it might be on Discord because we had 5 people in the Discord channel for a while, and now it's just you and me.
That's true.
So who knows? Yeah,
but now your quality is up again. I can read everything.
Huh. Yeah, I have a
I'm
feeling...
only watching in a window, so yeah.
I've been threatening to call my internet service provider because it's fiber optic, so there's no reason why it should be. There should be no reason. They probably just want me to pay more money for higher bandwidth, or they've artificially capped me, something like that.
In Sweden, we have a company that's basically cable TV, and you have fiber to the connection box, and then they are using normal coax from there in their network.
That's weird.
So it's like hybrid fiber, they call it. So it's not fiber all the way. Like what?
What's weird is that coax is it's not electrical. It's radio signals, right?
Yeah, exactly.
So there's a
basically fully analog, but in a cable instead of air.
Yeah, really interesting. All right, so even though David's gone, I think I found what he was talking about, which is assembly features right up here. So whole series. We're just going to play with this. Sketch the new holes or slots or existing holes. So, wow, okay. Okay. What's the position? Counterbore. I think there was a whole, oh yeah, size 0, 0. So let's say this is, let's do metric, anti-metric. Oh, so it actually is making the fastener and the...
Wow.
Oh, looks that's super nice. Cool. 6.
And you can do countersink and everything in one.
Yeah. Oh, that's super cool.
Could you choose where to thread it as well? Like...
Let me look. So...
Because this is just a through hole now.
Yeah. What's this? Middle hole specification. Auto size based on start hole. End hole specification. Yeah, there you go. And the end one is going to be bottoming. Well, there should be a through tapped hole. No, here we go. Tapped hole.
Yeah, and you can have it bottom out halfway and stuff.
Oh man, that is super cool.
Another point for SolidWorks.
Yeah. I mean, yeah, because the alternative is to edit a chamfer in this one part, and yeah, that's super cool. What's weird though, so that's an assembly feature up here. And the way we normally draw stuff is for to have the holes and then line the holes up against each other so that they, like you're doing the alignment of the assembly with the bolt holes that you've made for it. You're not doing the bolt holes later.
Yeah, exactly.
Yeah, this is super cool though. It kind of changes my concept of how you would do this. Let's see.
I mean, then everything is already done, and then you just put in the holes where you want them.
Yeah.
I mean, it's like the backwards way of doing it. I mean, I would always define like a common, like, oh, this is the origin because here I have a bolt hole that I know will.
Right.
Yeah.
But maybe if you have reference geometry where you have the, you just kind of say this is the bolt hole location, and you just have a point, but you don't actually draw the feature, right? Then you can do the alignment based on where you intend to have a fastener, if that's the thing, right? I think like on the MMX, we have a lot of things that are concentric on shafts, right?
Oh, now Mr. Comcast is back.
Hey, I'm not back. I'm actually, well, I am.
He's on his phone.
My Wi-Fi is. No, I'm on my iPad. My Wi-Fi is down. I don't know what the hell happened, but there's nothing on my Wi-Fi at all.
El Monsieur iPad. It's funny.
So I'm just gonna be watching, but okay. So
we have figured it out in your absence, David. We wouldn't have known that it existed.
Okay.
But we figured it out. We did an assembly feature, and we did we basically added an M6 bolt through 3 different things, and
yes,
we were looking at it, and it looked like the middle hole specification, the end hole. We added a thread to the end hole. It gave us the tap drill for an M6 as the bottom hole, and it gave us a countersink on the top side. It was beautiful.
Yeah, if you want to avoid interferences after you put the fastener in, then just make sure you select the one where it actually drills a hole that's the same size as the major diameter.
Right.
I don't know if you did that because you went pretty fast. But the other thing is, if you have your toolbox loaded before you start that, then you can add the fastener in that feature. You don't actually need to do it separately.
Oh well, let's try it again then. I just loaded the toolbox. I didn't have it before. Why is it so wide? Yikes! All right. NC metric, bolts and screws.
Are you going ANSI, huh?
Oh, what should I do?
Well, I would just pick ISO personally, but I mean, it's your call. Like, you can do what you want.
I don't think I know the difference.
Well, I think functionally there probably isn't one.
Yeah.
But this is a European project.
Good point. Who is that?
Sorry.
Who is that? Someone very cute.
That's my 3-year-old.
That happens with Maureen all the time, and she is, at least for the live stream, she's very clear she does not want her kids on YouTube at all. So it's always been like drama if a kid rolls into a room and starts making noise or is on camera. But she has a kid about, I think her kid's maybe 4. Yeah, I love that. I love the kid intrusions. All right, so let's try.
He's just playing Fire Track here. So, yeah. I can have him on if you want to hear, but I guess it's...
So we're gonna do another whole series. We're gonna put it there, and it's going to be.
Oh yeah, now you got smart fasteners available too. That's good.
Yeah,
I see it.
Oh yeah, the smart fastener tab is there. That's cool. So this one's going to be an M10, and it's going to be countersunk and
Counterboard.
Counterboard, yes. The last one is also going to be threaded tapped hole. M10.
Make sure you select the end component. There you go.
Awesome. Place fastener. Working.
And I guess you can define like how much stick out you want and the length and everything.
Yeah, you can do all that stuff.
Oh man.
Could you add nuts on it and washers and stuff? As well?
Yeah. You see how it says add to top stack right there? That's where you put washers.
Oh my gosh. Oh, that's the top stack. What about the bottom stack?
Pull down on that menu. See, there's a. There you go. Oh, okay. Never mind.
See, I added a washer up here.
Yeah. Well, because you threaded the bottom one, it's not going to ask you for.
Okay. Well, let's go back then. See if it's a clearance hole. Now I'm going back this. Yeah, there we go. Bottom stack.
Yeah.
Dude, that is sweet.
Wow.
Regular flat washer. That is. Now, what would be
Tim,
awesome
this
is
is
that it
cat.
allowed me to. Kooky saying, "Don't tell Martin about the washers." That's so true. If you're like, okay, how many washers can I add here?
Yeah.
Oh man, so external tooth lock washer, adding that on there. It takes a second for it to populate, but there it is. Hot damn.
Yep.
Hex nut style 1 style. I don't know what these.
Does it have the entire McMaster catalog here, so you can do?
I hope so.
So okay, I'm glad you brought that up, Lund, because the one downfall to all of this is that they're not currently set up to have McMaster car part numbers assigned to the smart fasteners, and so therefore the McMaster add-in isn't going to see them.
Yep.
And I actually haven't really tried to like override that somehow. I want to figure that out, because it gives you that shopping list.
Damn.
Yeah, look at that.
Of course I did. This is not right. I added I have to change that.
Yeah, but Tim, this is CAD, man. This is how you design stuff.
Yeah.
This is the simple stuff.
Yeah.
And I know it's exciting, but.
Yeah. What did I do with the fastener? I need to change that. X bolt.
It was something you did in the first. I mean, you added this the washer to the top stack.
It was the kind of hole at the beginning that changes.
Yeah, but I would think that you. All right. Well, I'm not going to. Already, the feature is super cool. I obviously did something wrong there, but it might be that I had. Did I have hex bolts? No, I didn't. I was wondering if there's something over here. In component, in condition. I love this. All right, so David, so while you were gone, we were asking about, because a lot of times we use in the context of an assembly, right? We will use fastener locations for doing our mates, right?
Right.
So, like, let's say over here in Music Box Land, no, this one. It's not gonna let me change windows until I get out of this dialogue. Okay, think about it, SolidWorks. But anyway, so like, if we can use this feature to basically populate all of our hardware, right? Which I love the concept of, especially since it's going to add the nuts and all these other things, which you would ordinarily be going into some library and whatever.
Yeah.
Then it should be the case that in order to in different parts that are going to be mated with a bolt in the assembly or even in a subassembly, that the way to do that mate we shouldn't make the mounting holes in the individual parts and then use them for alignment purposes. We should make we should just make a reference geometry like an axis through that point, or a point for where the fastener is going to happen, and then align those reference geometries.
Yes, I'm glad you came to that conclusion, because that is exactly how you want to do it.
Yeah.
But you can also use an existing hole, by the way, if you wanted to. Now, I think that using an existing hole is kind of, in a way, a little bit lazy, especially considering you can do it here. But I think, like, for example, if my computer hadn't crashed and I lost all my Wi-Fi, I would be showing you right now how I built the crankshaft. And so the way that the crankshaft, and all the components are aligned, there's an axis that goes through it, but that axis is not defined by the crankshaft or the anything. It's defined by the intersection of the right plane and the top plane. So, and all the positions of the components are defined by offsets from the center line. So none of the parts actually even have like reference features, like a face or anything like that. None of it is based on that. It's all planes. And
right.
So if you do it with enough planning, you don't actually need to line up holes at all.
Yeah.
So.
Well, no, I like this because the aligning parts based on mounting holes presupposes it removes your ability to change the mounting holes.
Exactly.
You
There
know?
you go. That's the other part.
And I think that mounting hole should be a dependent feature, not a driving feature. Right.
Right. So, by the way, speaking of which, let's do multiple holes on this face, and you can edit the sketch afterwards. But before you do it, I want you to select a face.
Okay.
Now, doing that guarantees that it's a 2-dimensional sketch, not a 3-dimensional sketch. So when you go and edit it, you'll have a different kind of control over it. If you had just selected the feature whole series, it would have made you go through a 3D sketch. But now you could put your holes wherever you want them, and then you can actually, in that sketch or even afterwards, you can do it just like the hole wizard, where you just you put points where you want them geometrically, etc.
Oh, so here's where I had gotten this. This is going to be a hex cap screw, and it's countersunk. That's where I got the other one wrong. Fit normal.
Yeah.
Okay, middle point, auto size. Last one is going to be end component is this one. End condition through all. Place fastener. Love it. And now we have, I still have a hex cap screw. I wonder why it did that.
Oh, that's weird.
Socket button. There we go. Actually, I didn't even want that. I want socket head cap screw. I don't want it to be better.
Yeah, there you go.
It just takes a while. Sometimes you make changes and you think it's going to happen instantly, and it needs to talk to its buddies up in the cloud. And does that fit? It does fit. And it's just but you see now that actually the countersink is too thick for the for that top plate. I have an M10 bolt in a 6mm plate. So options, head clearance. Is that it? That's probably it.
No, that makes the counterbore deeper.
Oh, or it makes it wider.
Try a negative. Oh, it makes it wider?
I think so. Oh, no. It still doesn't line it up right. It's still lining it up from the shoulder here.
Well, the shoulder is where socketed cap screws are measured from.
Yeah, but it's not lining it up from the bottom of the countersink. Anyway, this is super cool. We don't need to totally dial this in today.
Yeah, right.
But I do like the implications. I like the discussing the implications for. So
I think a big risk would be that you would miss clearances in the middle parts when you do it like that. I mean, you don't necessarily go in and check that you have the correct clearance in the sketches if you just add random fasteners later. So,
yeah.
Of course, that's part of it, but I mean, that would be my main question about this approach.
Well, so there are two features that we haven't even looked at yet. They're both under the Evaluate tab, and one of them is going to be once you have your fasteners in there, you do what's called an interference detection, and then you can also do a alignment check where it actually looks at your fastener holes and sees if they line up or not, and it will do that for you.
Awesome! You can do weld beads in this.
Yeah.
Why wouldn't it do a weld bead for me? Weld path right there. Dude. Did it do it or did it not do it? It didn't do it.
No, I mean, I saw the weld symbol.
Yeah. Weld bead. Oh, it wants to do it between here and here. It's looking for faces. Yeah, is that going to do it? But there's no representation of where the weld is. It's not like in the features here.
Right, but there's a folder in the feature
weld
tree.
folder. Hot damn, there it is.
Yeah.
And they're both in there. Maybe I don't have visibility
Yeah.
for welds on. There it is.
Oh, that's probably it, actually.
Yeah,
Yeah.
that is it. Come on. Delete that second one. Yes. I hate the fact that you can click this eye and not click everything else. Come on.
You got to click the actual eye.
I know.
There you go. Click that. There you go. There's your weld bead.
That is so cool. That is so cool. Because I mean, that's the other thing, right? We're gonna have a bunch of stuff, and we do have a bunch of the stuff on MMX, which is welded together, and so we have no way of communicating what that's going to be any other way.
Well, I mean this is how you just fillets or stuff, but this is so much better.
Yeah.
Yeah.
We need to have like a list of like reasons why SolidWorks rocks.
Well,
even when
honestly,
you're doing dumb geometry like this.
Yeah. Again, I just had actually that conversation with somebody on CAD Team Chat this morning. He basically started, like he couldn't find a feature in SolidWorks, and I told him how to do it, and he's like, "Oh, but that's not easy. It's like, man, so much easier in Fusion." And I'm like, I don't know. Like, I kind of disagree that it's easier in Fusion. I think with SolidWorks, I think once you discover a feature, first of all, you almost can't live without it. But secondly, it turns out it's hiding in plain sight half the time.
I would say that doing things accurately, SolidWorks is probably better, but doing a quick sketch and not defining any constraints and stuff, then Fusion might be faster.
Yeah,
I don't know.
Could be.
I agree with that. I'm
quick and dirty. I think Fusion is the way, but yeah. But then you get all of the CAD files like Martin did them. So I mean,
right. Yeah, I think if you are in the design phase or the brainstorming phase, Fusion is better. It's just easier and faster, I think. But if you're going to be manufacturing something, I mean, yeah. And I do get that there's a learning curve, right? I mean, like this one with the Weldments feature, like knowing how to use the Weldments feature, like I can't do. I have angst trying to do like a tubular frame or something like that in Fusion, because it's like I know there's a really easier way and I don't have access to it, and it pisses me off.
Yeah.
So yeah, but I do I do have to I think, I mean, actually in the context of the MMX touring, right, it's not like we have the way that we're talking about doing this project is that we have ideation and we have discussion and we have collection of ideas from people, and they can use whatever platform they want, right? We have 20 seats of SolidWorks for this project. And so we're going to have the people that it's not going to be like, Martin wants to be as inclusive as possible, which is awesome. But I think in terms of like, hey, we're going to make, manufacturing ready parts where everything has the right clearance, like the holes have the right clearance, that, it's like, we're not going to be sourcing parts that, he has to ream out because it's, 0.25 inches instead of 2.257 for a clearance drill for a quarter. Okay, he shouldn't be using quarter-inch bolts. A bad example, but you know what I mean, right?
Good catch.
Yeah.
Good catch.
Sorry. But you know what I mean? So it's like I think we can develop our team of people, and it's going to be easier for us to have a good grasp of like, these are the standards we're going to use, and within that, again, it's a 20-person team still.
Yeah.
So it's not like it's a small team.
So by the way. On top of that, just so you know, I don't know if you've seen the same marketing materials I have.
Yeah.
I'm sure you probably have, since you're probably more plugged into Sean than I am. But starting, I think tomorrow, if I'm not mistaken, it's sometime in the next couple of weeks. SolidWorks is going to be $100 a year.
Yeah. For
SolidWorks Connected. It's cheaper than Fusion 360.
Yeah.
So like the whole 20 seats thing, it's great that we have it, but I mean, before too long, it's going to be essentially like they're giving them away.
Right. which makes sense for software. I think there's something that I think it's for. It's they have two different things. That the one for makers I think is in the third quarter, and there's another one. It's another price level. It's like for enthusiasts or for maker. There's two different ones that are coming out. But yeah,
okay.
I talked to Sean O'Neill just a couple weeks ago, and it was funny because when we started this whole conversation, one of the downsides of using SolidWorks was that it was less accessible to most people. And so, we had started the conversation with them saying, "Oh, could we get 80 seats?" It's like, that's a lot. I actually, part of me likes the idea of having a smaller team, so that because still 20 people is a lot of people, and I don't think we've ever done a parts assignment, where there's more than 20 parts being worked on at one time. So. I think it's going to be a reasonable sized team, but you're right, David. The ability for people to participate in the ideation phase in SolidWorks is going to be much better when that licensing changes. For sure.
And I would also say that this kind of project where no one is hired to do it, then people will switch in and out all the time, and moving all of these licenses around. It's much easier if you have more to spare.
Yeah, agreed.
Otherwise, you have to really keep check on everyone. That are you still working this week, or can I change it to someone else, or whatever?
Well, and again, this is like most volunteer organizations, right? You might have 100 members, but there's like 10% that do most of the work. So it acknowledges that as well. Yeah. Cool. So
what the hell happened to my Wi-Fi?
What was it, David?
I said, what the hell happened to my Wi-Fi? I don't know what the hell happened. It's just decided to crap out while I was talking before.
Yeah.
Sorry, I'm using to myself here.
So, what else, David? What was maybe I should pull it up on Discord. What else was on your agenda that you wanted to show us?
Oh yeah, can you just? Oh wow, our private message is great. Thanks.
Oh, am I streaming that now?
Yep.
Oh, I'm streaming it into Discord, but not into YouTube.
Okay. What did I say we were gonna do here? Sorry, I'm looking in my messages now. Yeah. Okay. Two main topics are building subassemblies and nested subassemblies, mate references, and smart fasteners. We talked about the smart fasteners. I touched on the mate references, but unfortunately, I got cut off. Yeah. I think, but I think I touched on them. But the idea is that you build a mate reference in advance, so that the when you drag a part in, and you can do that if you have two windows open, with one with the assembly and one with the part or the subassembly, then that mate reference will make it so that you don't have to do any mating whatsoever. You just drag it in and it will populate instantly in the correct spot. So if you build your reference geometry like planes, if you want to use points, you can do that, but planes, axes, so forth, then you can put them in the right spot for whatever the mating component is, and then assign a mate reference to it, and then just drag in your part, and literally no work whatsoever. It's just done. And I think that that's the best way to do it, because first of all, it also, like, if you drag it in and it populates and it's like upside down, well, that you did something wrong with setting that reference in the first place. So you have to so it's just as easy to say, oh, never mind, delete it from the subassembly and then reorient the mate reference to the right way, and then drag it in and try it again. And then if it goes properly that time, then okay, I did this right. It's sort of like a check on if your geometry is correct. So that's a good thing. And then once you do that, then you're good. So subassemblies, nested subassemblies, etc. I wanted to talk about the mate references in relation to that, and the idea, especially one of the reasons I picked the shaft, which I'm sorry I never got a chance to show before my internet died.
Is it on the cloud? Could I open it through, or is it in your own storage?
Well, I think I made MySpace visible. So if you go to my what do you call it? Collaborative space.
Yep.
You should be able to open. It should be called crankshaft assembly.
I'm looking for it. It's super slow. So I opened up a stepper motor that's in the music box, and I have a mate reference getting ready to be put in. So walk me through while I'm looking for that.
Okay. If you want to go with geometry, you can. If you want to go with planes, you can. But the first entity, I would pick the axis or some kind of shaft.
Okay. Well, I like to locate these by this. So if I wanted to use this,
that's fine. I would pick the face.
So the primary one would be that axis.
Right. The second would be the face.
The mating plane right there, or this plane here.
Yeah. And then the third would be like either the top or the right plane. I would pick the right plane.
The plane, or something that's orthogonal, or
or whatever, some third entity that exactly that would make sense.
Okay. Done.
So, yeah, and then you just place one of those. Say again.
Now, what does that get me?
What do you mean?
So I've done that. I've added that thing, and this is a part that I downloaded from GrabCAD or something. So you can see that someone made all these things are in Slovakian or something.
Yeah. So you would have.
Go ahead.
Sorry, waiting on you. Okay, so you would have to place that reference somewhere on this and name it the exact same thing in whatever it's like whatever the next level up assembly that it's going to be mated to.
So that would be in this punch head. I'm going to open this guy. So if I'm going to take this guy out. Well, let's suppress him for now. So if that motor that I just edited was right here, and it needs to come to this motor mount. I have to give it the same.
Yeah. So you go to that reference geometry, mate reference, and then do the exact same thing. You pick the face, the other face, and then whatever the third element that you picked was.
Okay. Let's try that. All right.
And you should be able to just drag it in. Okay, if it didn't populate automatically, then there was something wrong with your mate references.
Well, I don't think I actually deliberately named it.
I think the third thing you selected was the center plane for the axis, and I don't think you selected the same.
Yeah.
Okay, yeah, so that might be an issue. But the other part is they have to have the exact same name. I forgot to mention that. I'm sorry. So if you call one Steve, you can't call the other one John. They have to both be Steve.
Yeah. All right, so this one's named Steve. Okay, and I'm going to open this guy. And amongst all the Ukrainian stuff, I'm going to... Oh, there we go. Mate references is in English. Add a definition. This one's also named Steve. Yeah, but you're right. So yeah, that third reference is right through the middle of it. And this is parallel. See, there I don't actually have to have the plane that I pick actually be coincident with it. It can just be parallel.
Yeah, exactly.
So that should work.
Right.
All right, so I'm going to save that guy. And I'm going to swap back to this guy. And it's still saving. That's weird. Since I'm streaming the window, I have a progress bar blocking my whole screen, but you guys can't see it. All right, so now I go back to this guy. No, that's not the one I want. I want punch head, this one. All right, so now I'm going to delete that, and I'm going to try it again. Insert components.
You might have to drag it in. Like I actually didn't do it this way. I dragged it in from like split the screen so that you have the left side is the subassembly, the right side's the part. Then drag it from there. So just
configuration. Oh, I didn't realize you could change configurations. Yeah, configuration is something I'm not. I've never actually used.
Yeah. So in the top right hand corner, you'll see like the whole like move to the left or tile. Right now, pick your motor wherever that is. There you go. Now tile that to the right.
Come on. There we go.
Yeah. Now grab the title bar. That's the way I see it works usually better. Oh, it didn't do it automatically, which means there's something isn't right. It could be that you have to change the alignment.
But so I have Steve here on the left, and I have Steve on the right.
Yeah, it only aligns. It only snaps in. Sorry, if all of the parameters of that mate reference match each other and are applicable. So it can get tricky. But once you get it, it's fast.
So, but given that it's tricky, right? What is the application for this in the MMX? Because it seems that there. I mean, or where would it be a better idea to do it this way than any other way?
The reason is because it's really flipping fast. So when you build like a subassembly, in fact, perfect example, to make the crankshaft assembly, all I have to do is drag in the shaft. I drag in the crank handle subassembly. I drag in the what do you call it? The cymbal beaters / flywheel pulley subassembly, and
the rhythm machine.
Yeah, thank you. Rhythm machine subassembly, and then the third one is the crank gear subassembly. There's 3 of them on the crankshaft, and literally I can build, delete 5 times in a minute, and that's why it's like beneficial. But more importantly is that it's a check on whether you did it right. So that's a bigger deal. If that doesn't matter,
it's like you're interfacing how this interacts with something else. That's like the obvious way to do it. I mean, it's the same. Again, I'm talking about programming, but I mean, it's the same here. I mean, when you have modules, you define an interface, how they communicate.
Exactly.
And here you're doing it with positions and relative like constraints and stuff.
Yeah. And if it doesn't work, that just tells you that there's more to know. And when it does drag in perfectly, then you know it's good. And I can tell you right now, based on what I just saw, like there's something wrong with that mate reference.
Well, you know what's interesting is that it's trying to put it in here now. I just dragged it in, and I mean, I can see here that it's. You guys can't see the tooltips that pop up on YouTube. It's interesting. So it's at least trying to do it.
Huh.
Maybe it's because
it might be that, I mean, the constraint on the circle is equal radius and not like collinear or something. I don't know. I mean, you had many options to choose from, I guess.
Yeah. Well, I think what happened is that when I dragged it in, I had these cursors here where it was like I was trying to add a thing. Maybe I just.
Well, when it's working right, it's instant. You don't have to. I mean, all you do is drag it across into the window, and poof, it's in the right spot.
Look, there's suppressed components. This mate cannot be solved because it has 1 or more suppressed components.
Huh.
Maybe it's because this guy is suppressed?
Maybe it's the Ukrainian stuff.
Yeah.
Oh, that could be another thing. Like you've got things interfering with each other.
Okay, well, but we do see, though, that it's coming in. These are... Look at that. It also might be that these 2 different things are, this is a derivation of the other component. See, I just renamed it. So I might be, because I'm reinserting something that's already been kind of, I brought in the same part, but then made it independent. It might be doing that. But when you look at these, oh no, this mate is there. This mate was, this is how anyway. Okay, that's cool. So the question remains, though, when can we line up things based on very simple geometry, like individual points or faces or planes, and when do we use this other thing?
Well, so in general, I think what I've been going off of is to not use physical faces at all if you can avoid it, unless there's a very good reason to. It's deliberately making reference geometry when you make the geometry that you're making that interface with its neighbor's reference geometry. And also, not only that, but making sure that when you mate something, you're mating it to something logically, not just because it's next to it, right? Like, for example, mating the motor to the face of that plate sounds good on its face, right? Pun intended there. But are you mating the motor to like some kind of like electronics subassembly, or is it like some kind of moving other thing? Is there a reason that you're doing it to those two physical objects directly, or does it make more sense to say, okay, this is my like center of my face, or like this axis and this plane represent the face of my motor, and this axis and this plane represent the face of this machine.
Right.
What does this motor report to? Does it report to that plate, or does it report to the machine? And then you pick which one that you want it to do. And
so for example,
not having seen this before, it's hard to tell.
Yeah. So for this example, this mate that I have lined up here, right? This is a thing that actually kind of bugs me. Even though I did it in this part, just probably because it was quicker, right? Is that these parts are not really actually interacting, right, on this geometry, right? So for me to lock the rotation of this part, I added this parallel constraint. And if I don't have that, then this should be able to spin, right? I've located it based on this little feature here in the hole, right? In the real world, they would interfere, and that's it makes more sense to lock it down, to me, to lock the rotation down by picking one of these and then picking the hole that it's going to go to. Is that kind of what you're saying?
But if you take...
Huh?
Sort of. What I've been doing actually is picking like mid planes, right? And picking making them coincident to an axis or something like that. It's hard to explain without me showing you on SolidWorks, but unfortunately I can't do that right now. But what I'm trying to get at is, instead of mating a physical thing to another physical thing, think of a mate as like plugging something that you have into the hole and deciding where it goes from there. It's sort of like taking your thing, going all the way up to the top and saying, okay, I'm taking this motor and I'm putting it in the music box, and then going down the music box and figuring out where the first place is that it's appropriate for it to go. So when I think about the crankshaft, I just built a crankshaft that's connected to a pulley, right? And that pulley runs the sun gear. So so seems like I am definitely putting it into the crankshaft. I'm not going above that, right? So that's the place I'm going to settle. But at what level do I mate it? Do I mate it so that when I turn the handle, it just spins freely because it's a free spinning thing, or does it drive the crankshaft itself? Actually, it's the interface and it drives the crankshaft. So I'm mating the pulley to the crankshaft itself, not to the shaft. I'm sorry, the crankshaft assembly, not to the crankshaft. You see what I mean? That's the difference.
Yeah.
I could mate it to the crankshaft, and then I would mate the crankshaft to the the next subassembly, and then whatever. But I think that it's better to mate the shaft itself to the crankshaft assembly the same way I mate the other stuff to the crankshaft assembly. That way, if anything changes on any of these things, then it's reflected downstream the same way, instead of having them be interdependent on each other.
Yeah. So,
and I don't know how to define that for your machine. It might be different.
Yeah. Well, no. So, for example, if you see, I just went into this part, right? I have a motor mount plate that I had drawn, and I drew the fastener locations, and I drew where I wanted the stepper motor to be, right? And then when I brought the stepper motor in, I lined it up to the plate. right?
Mm-hmm.
If I'm trying to kind of like make an example of what you're saying and apply it here, what I could also do is then I just took away all the holes in that motor mount. I could align this thing. This is my reference geometry in the middle, right? I have 2 linear bearings, and I have where the lead screw nut's going to go. Oops, that one moved.
Mm-hmm.
That shouldn't move. Sorry, let me ground that for a moment. I'm going to get rid of my mate references. Yes. All right. So I'm gonna mate this to that, right? And because I have that, now I should be able to use, right? So I'm lining it up based on I'm mating it to the reference geometry, and instead of adding the holes and lining it up with the holes, now I'm going to give it a do I need hole series or do I need hole wizard?
Are you doing it at the?
I just want to put the holes into this motor mount.
I mean, you could do it with. I mean, the whole series will give you the smart fasteners all in one shot. So I would suggest that. It also I mentioned earlier that the whole series also asks you if you want to use existing holes, and you do have existing holes in that motor.
Yep. Yeah, the first one defaults a little weird, but
looks like you're kind of doing it backwards here.
I get accused of that quite a bit.
Wait, do they bolt into the motor, or do they bolt?
I think they bolt into the motor. Yeah.
Oh, I didn't realize the motor had threads. Sorry, I was working on something.
Yeah, some don't. I'm pretty sure this one does. Now I'm going to countersink these in because they're going to be there. They're not going to be M10. They're going to be M3.
Remember, you can do this alignment once you've done the feature. You can actually go in and align them to the holes, in a real sketch.
Right. Interesting. So then the middle one, there is no middle one. End hole specification. This is the end component right here. And it is threaded. Interesting. So, and I want to go in. I'm going to say this is going to go in 5 millimeters. Blind. No, this is going to be 5 millimeters. Okay. And the smart fastener, place fastener. I'm going to be able to go back and edit that first sketch, right? Because the first one I had to just place on the face kind of willy-nilly.
Yeah, you might end up having to do like a couple of visits. Like, for example, rattle off a quick fastener stack and then go back to your sketch, align them, and then go back and then finish your fastener stack. I don't know. Maybe you can, maybe you can't. It's hard to do remotely to show you how to do that.
Not flathead screw, socket, countersunk. There we go.
Yeah, it's easy to confuse those two. I actually did that several times at the beginning, where I picked, oh yeah, it's countersunk, and then it turns out it was like a Phillips head.
Right. I think I'm waiting for the. There we go. Sometimes it's not always intuitive. I love this, how this is doing it. Look, now it's thread length. Length is too long, so we're going to go 10 millimeters. Auto update length. Yes.
Just remember that the countersunk screws, the length is from the top of the head.
Right. Well, I can see how far they're going into my thing, so I know that is too much. That is awesome. No valid edges for cosmetic creation. Interesting.
Well,
yeah, now I need to go into this guy and edit. Oops, not that one. This guy and edit the location sketch.
Yep.
And get rid of this one. What was that? It's Sketch entities can not delete from the derived sketch. Please underive the sketch before changing. What does that mean? Underive.
I don't know. You're going blurry there. I can't really see what you're doing.
Yeah.
I'm on cellular right now. In fact, I don't even know how much data this is hogging from me now. Might be a lot.
All right, now I'm going to edit this sketch, and I'm going to delete that.
What happened to my freaking Wi-Fi? What is up with this?
All right. Oops. Oh, it's.
I mean, it's brainy for me too. There's something messing up with Tim.
It's probably my thing. The what's cool? So I actually deleted the. I was able to delete the hole, but then not the fastener. So, so this guy needs to go away now. Anyway, I really don't like that in the whole wizard how it makes you select a geometry before you can like put any reference geometry in there. But it is super cool, I think, that we just align the motor to the actual reference geometry and then put in the holes with the motor.
That So essentially, that's why you have that layout sketch. That's kind of what it's for. It's for downstream reference geometry, not necessarily for modeling.
Yeah. Well, it also makes more sense when you're saying that you want to do everything with the minimum geometry in the layout sketch, right? Because the if the motors are in a weird place, or if you change get a motor that has a different bolt size or bolt whatever. I love that you can do these kind of features that are across parts, and they integrate things from both parts. I love that. That makes sense. Because before I was putting like the bolt holes for these things into my reference geometry sketch because I wanted to use those for alignment later.
Yeah. Yeah, you don't need to really.
Yeah, that's cool. Awesome. All right. So where are we at? What's next steps? We're gonna end this in 4 minutes. So
were you gonna open the shaft or no?
Oh, let me see if I can. I started.
If you only got 4 minutes, maybe it's not worth it.
Let's save that. Well, and hopefully we'll get you. It's funny. I got into common space, and that's not your project. This is not the common. This is all hardware. Yeah, I don't see it. Let's do that next week.
Yeah, sounds good.
Okay. So what does this mean? So we should try in the intervening week. Let's try to pull up and share. We'll do it. We'll share it with people on Discord also. Kind of like what the CAD standards is. Mention some of these assembly features, how we lay things out. Here with the music box. The first thing we did on this stream was to show how the reference geometry nests. Well, this isn't the music box. This is just the punch head. This is a subassembly. But we should try to start codifying this so that we have some kind of working understanding of how this is all going to go together.
Yeah, I think it's a great idea. I mean, we were going to use the crankshaft, I think, as an example. Unfortunately, I died out. But I mean, we can figure out something. I think it's a good example to start with, at least as a working model.
Yeah. Okay.
Let's do that for this week. Then that'll be my goal.
Yeah, and then you'll be rebuilding a new computer with liquid cooling.
Yeah. Oh man, this thing is gonna get liquid cooling if I get anywhere near the river anytime soon. Seriously, I'm about to throw it in.
fully submersive liquid cooling.
Yeah.
Sweet. All right, guys. Well,
I think I saw that Linus Tech Tips did that on a laptop not too far well.
Did it work?
I mean, it wasn't very practical, but it worked, I think.
Oh, man.
Awesome. All right, guys. Well, thank you for hanging out this week. David, thanks again for being here. And we'll get into the crankshaft. We'll get into some more standards. And hopefully I'll have this punching head a lot more better developed on the the music box project by next week, and we'll start to talk about control interface issues.
Sounds good.
All right, guys.
But
Thanks,
the punching head is to make new tape, or
yeah, for punching the music, and then you'd be able to swap it out and play it back with the same machine, but just you'd swap out this head and have a playback mechanism. That's a module that pops in and out.
So the solenoid is to punch holes in the tape.
Yeah, the solenoid may not be strong enough. I have Dan Carroll is supposed to be measuring the force it takes to punch. I know the specs for this, how much force it exerts, but I need to line it up with the real world. If it works this way, I think this is mechanically very simple, but solenoids are not that strong, so I don't know if this would do the job or not.
Yeah, there has been a lot of discussions to try to make like a MIDI interface for the MMX with solenoids, and everyone has been like, maybe not.
Yeah.
Either you have a very short stroke or you have very low force.
Right.
So,
it's all about pneumatics these days.
Yeah.
All right, guys. Thanks again, and we'll chat next week.